All right. Hello again from United Astronomy Clubs of New Jersey. Happy New Year. Hopefully, everyone got through the season well. We're glad to be back. We are once again online only during the winter. Uh, we have finally gotten some snow. It is actively snowing outside, so while not a great night for viewing, it is a good night to find out what is going to be up in the sky this month. So I want to welcome everyone here. As always, a couple notes. Do check us out on our website, uacnj.org. That's where you're going to find a list of all our member clubs, our upcoming talks, and any special events that we might be hosting. We're hoping to get a special event for the solar eclipse in April going for everyone. So that is in the works now officially. Uh, Looking forward to a couple other things, hopefully, but those will come later. You can also check us out on our socials, our Facebook, our Instagram. We have our Discord channel where you can always ask those questions, post those space photos. We love to see that. And as always, we do live stream these presentations on Twitch and YouTube. And always hit those like and subscribe. Follow us on Twitch. Always helps us get those numbers out there so we can share our love of astronomy and space with everyone that we can. With that being said, tonight's talk is What's Up in the January Sky with Lonny Buinis. Lonny has been giving the What's Up series since UACNJ opened in 1994. He received degrees from Stevens Institute of Technology in Physics and Computer Science, then learned space art, animation, and video on his own. Lonny is the only member of the IAAA.org who specializes in virtual reality worlds. He wrote the first interactive space history ebook and is most pleased to have married Jan, his narrator. And with that, here's Lonny.
Thank you very much, Kim. Really appreciate that. Everything that you and Chris and Jeff and all of the UACNJ members do to make this possible. There's a lot going on behind the scenes, everyone, that you don't know. A lot of tech going on to make this possible. So we're talking about what's up every month. Every month it's a different view of the sky. 1/12 of the way around as the Earth circles the sun. And this time of the year, we're facing towards the winter triangle and the winter hexagon, which I drew out on my opening image. And I will be pointing these out when we simulate the sky later in some free computer programs that you can download or use for yourselves. Absolutely free. There's a lot of cool free stuff out there. I'm going to select the middle of January. This is January 15th view. And so we're going to be taking a live simulated live look at the sky you would have seen tonight if it weren't snowing. When you do visit UACNJ between April and October when it's not too cold, and we do these live outside, excuse me, then we show you this. Basic guide information like use your headlights when leaving so you don't drive off the road. But we're not going to see this right now because we're going to talk about things virtually. And this month, I got my list of events from go-astronomy.com. I don't work for any of the sites that I'm going to quote, but I'll be giving you some references. So I hope you're all home taking notes, vigorous typing away on your mobile devices. Some of us using pencil and paper. I know many of us don't know what those are.
Lonny, can you pause for just a second? We're getting a wicked echo.
Okay. Might be some room acoustics here, a little bit. I can reduce my volume if that helps. Pardon us, folks.
All right, so try again now.
Yeah, I'm displaying a list of events that you can get for the whole year at go-astronomy.com website. Please let us know if you're having trouble. Yeah, thank you, Kim. And at home, you can always let us know if you're having trouble in chat or with our technical staff. So I'm going to start with a meteor shower this month. It's a minor shower, the quadrantids. You could see them in theory between late December and mid-January, but this is an unusual shower with a very narrow peak within a few hours even for the maximum. So the best thing to do is go back in time to 3 days ago. Because today is no longer January 3rd. I'm hoping that some of us will go out around midnight and look for this debris left over from a minor planet or a comet. We're not entirely sure. Might be an asteroid with the sexy name 2003 EH1. The meteors seem to streak out in all directions from a single point, and yet we're passing through a parallel track of debris, the orbit of an old minor planet or comet that left junk behind. So why does it seem to be coming from a point? That's perspective, just like looking at railroad tracks that meet in the distance or highway markers, lane markers. They don't really meet. We know they don't because they're parallel, but in the vast, vast distance, it seems to be a point that they're coming from. Up to 120 per hour, that's amazing. But I say it's a minor shower because it's very hard to hit that peak. And these are rather faint meteors. We've got a couple of phases of the moon every month. Sometimes we have 2 full moons in a month because the month is longer than it takes the time it takes for the moon to go through its phases. But not this month. 1 new moon, 1 full moon. Early in the month, it's a good time to see faint objects because the moon is new. When the moon is full, forget about seeing faint nebulae, nebulas, take your pick, nebulae, nebulas, gas clouds, or star clusters. But you could still see bright planets and stars during the full moon, and that's the end of the month. I'd like to get my information about the moon from moongiant.com, Moon Giant. That's the current phase. It's called a crescent. And if you look carefully in the real sky, you might see the new moon in the old moon's arms. The dark side of the moon is lit up by reflected light. Where is that light coming from? Think about it. It looks kind of bluish in the real sky. And that would be Earth light, the light of Earth reflected off the dark side of the moon. So right now the moon is in crescent phase. By the time it stops snowing in a few days and raining, actually they're saying Monday should be partly sunny. We should be able to see the moon when? Waning. The waning phases in the morning. The bright side of the moon is facing left as you're looking south. That's east with the rising sun. So you got to get up early. Here's all the phases of the moon. You can turn them off and on this chart from moongiant.com. Very nice. You can print it. Really makes a nice calendar. They do this every month. This month is unusual. All the major phases of the moon line up on the same day each week, Thursday. Look at that. Last quarter moon, that's waning. Morning sky, look due south, you'll see half the moon lit up. Later in the month, the 18th, you can do it at night as the sun sets to the right, west. If you're facing south, west is to your right. Half of the moon is lit up, and it's at a decent hour. As the sun sets, we can see the first quarter moon with half the moon lit up. So why on Earth, why on moon, is it called quarter moon if it's half lit up? Now, where's the other side of the moon? It's facing away from us. So there is another 2 quarters on the other side. We don't see those. The moon always faces the Earth in one direction because of locked rotation, synchronous rotation. All of the major moons of the solar system do this with their parent planets. They all face their planet permanently by tidal forces. Tides slowed down the rotation of the moon over eons until it rotates the same rate that it goes around the Earth. about 30 days. 30 days to orbit, 30 days to rotate. So it's locked rotation. So don't look for faint objects at the end of the month. Look for details on the moon with a telescope or binoculars. You'll see nice shadowing because the sun is coming in at a raking angle. Scientific terminology, raking angle. I made that up. You like it? I'm going to make up some stuff, so don't believe everything you hear tonight. Challenge me, right? Do some fact checking. New moon, that's when it's in the sky near the sun. Great time to see faint objects at night because the moon's not there interfering. So 4, 11, 18, 25, just keep adding 7 to 4. We are here on the 6th. Every month, there is a special name for the full moon. Did you know there's also a special name for the new moon? I didn't know that until my whole life, until just a few months ago. Right, I get these names from Wikipedia, great encyclopedia, online, free, but they do take donations because it's all volunteer work. This is the difficulty moon, the black smoke moon of January. It's according to a reference used by the Cub Scouts and the Boy Scouts for many decades. Or the wolf moon. There's some really cool names in the Farm's Almanac taken from Native Americans. And they have actually 3, if you look them up, 3 main ones this month. I like the Algonquian Indians or Native Americans, Squochi Quesos, literally translated, the sun has not strength to thaw. It's a weak sun. Why? Why is it cold in winter? It's because we're closest to the sun in winter. Did you know that? We are. The Earth is not orbiting the sun in a circle. It's an ellipse. It's closer to the sun in northern hemisphere winter. So why isn't it warm? Harvard students get this question wrong. They were interviewed years ago. Most of them taken at random, leaving their classes in Harvard, a prestigious university, did not know why we have seasons. It's because the Earth is tilted to the sun and we face away from the sun in northern hemisphere winter. The sunlight coming in is weak, spread out over the ground more, and so we have cold. Other names: old moon, moon after Yule, winter moon. Pick your favorite. I like wolf moon. That's pretty poetic. Wolf moon, January. We also have a planet that's a good time to see once roughly every month. Mercury goes around the sun much faster than the Earth does. I just had a birthday recently. I turned 259 in Mercury years, 88 days to go around once. January 12th, look for Mercury. Western elongation. What does that mean? It's elongated away from the sun, its greatest angle away from the sun. Since Mercury is closest to the sun, it always spends its time in the sky close to the sun. Last month, I talked about greatest elongation east, not west. And when Mercury is elongated east, let's think about our directions. Facing south, the sun sets to your right, that's west. The sun rises to your left in the east. If it's east or left of the sun, that must mean that Mercury followed the setting sun. So eastern elongation is in the night sky. And this month, on the 12th at 6 a.m., you want to look early. Mercury is a morning star, just like Venus, much brighter, much more brilliant, closer to a second planet from the sun. But to find the first planet, it's difficult to do. You got to do it close to sunrise this month. So it's its greatest distance and angle away from the sun. Not very far. And that's the current phase of Mercury. Very similar to the phase of the moon later this month, which is a gibbous phase. There's also some really cool stuff happening with the moons of Jupiter, and we can simulate these configurations that Joe Rao, meteorologist and amateur astronomer, wrote about in Sky and Telescope magazine this month. Also online, You can subscribe to it. You can buy it as a paper product. You can get most of it free. You can see Joe Rayo's article for free at skyandtelescope.org for organization. Let's take a look at on January 11th at Universal Time 23 hours. There's an interesting configuration of the four big moons seen by Galileo 413 years ago. And I can simulate that in Stellarium, which is a free computer program that you can get, again, for free. There's Jupiter, Io, Europa, Ganymede, Callisto is the order closest to Jupiter to furthest. Io, Europa, Ganymede, and then Callisto, all orbiting fairly close to Jupiter, so they take only days to orbit the planet, not years, not even 88 days like Mercury. This is the way Jupiter would look in a small telescope or pair of binoculars. I have seen all four moons of Jupiter in binoculars. But on the 11th, late at night, that's the 12th, the universal time that Joe Rail was talking about, you'll see the four moons with two pairs all lined up like this. They go back and forth. They're not they orbit in the plane of Jupiter's equator, but Jupiter is tipped a little bit to its orbit around the sun. Not like the Earth, 23.5 degrees. Jupiter only about 3 degrees. But this month, it's tipped toward us. And so the moons don't seem to line up quite straight. There's another cool configuration on January 21st. Can we see what that looks like in Stellarium? Sure we can. Because I can set the date. What was that, 24th? Whoops. Actually, I'm hitting the month instead of the day. Nicely spread out, all four moons. But that was January 21st. So I got that wrong. 21st, let's try that. The brightest of the four is also the smallest moon. Isn't that weird? Covered with bright ice, Europa. You will never see it like this in a telescope from Earth. It's way too far away and too small, smaller than our moon. But this, my friends, may be the place we want to look for advanced life, not primitive life, advanced life in our own solar system, life that evolved independently from life on Earth. Underneath, we know there is a warm ocean that's been warm for billions of years. Organic matter is there, hydrocarbons, stuff that might make up life. How do we know if there's advanced life? There's only one way to find out, and that's to land something there. There is a planned orbiter mission to Europa. There may be a lander that will drill through the thinnest part of the ice to see if microbes have percolated up. But I hope that I live long enough to see a mission to explore under the ice of Europa, a moon that you can see even in a pair of binoculars. Let's zoom out, find out where Jupiter is this month as we look at a star map facing south. And that's Stellarium. So let's take a look. I'm going to stick with Stellarium for the next few minutes. Again, a program that you can get for free. And it's a good idea not to get too overwhelmed by looking at the whole sky, the way it appears on a star map called a planisphere. Planisphere is a kind of star map we sell at our gift shop, shameless plug, at UACNJ. Come and visit, buy one of our inexpensive star charts. It's a good way to get started. Now I'm going to spin the chart just as I would on the paper map and start getting oriented to the sky by facing north, where the constellations never rise or set. They just spin around the North Star, Polaris. In the real sky, 3 in the morning, heavens no. Are we still, whoops, time is a little bit off here. Went to the wrong year, in the middle of January 2024. As it just gets dark enough, we're going to find the Big Dipper low in the sky, might be hidden by trees where you live. In the real sky, these constellations are enormous. Sometimes you have to move your head side to side to see the whole thing. Can you tell what Ursa Major is? Big Dipper's only part. It's an asterism, a star picture. But this is a constellation, one of 88 officially recognized by the International Astronomical Union almost a century ago. Ursa, Bear, Major, Big. Ursa Major. If there's a big bear, there must be a little bear, which you can always find by looking for a picture of the bear in the sky. No. Looking for a little dipper in the real sky. No. What you want to do is look for the pointer stars in the bowl of the Big Dipper and go about 5 times their distance apart till you come to here. And the north pole of the Earth points in space close to that star, about where my arrow is. Very close. It won't always do that. The Earth is wobbling. Yep, it's wobbling like a top running out of energy. And so eventually it will point to a bright star in the summer sky, Vega or Vega. That's going to be our pole star in the year 10,000 AD. Stick around. But for right now, that constellation marks where our North Pole is pointing. Do they have a South Pole star in the Southern Hemisphere, Australia, South America, Africa, South Africa? Nope. No, they have a cross that points to roughly where the South Pole is. Between the two dippers, long constellation Draco, dragon. That was our pole star, Thuban, Alpha Draconis. Alpha, brightest star in Draco, the dragon, Alpha Draconis. The Greek letters mark how bright the stars are. Brightest star in Ursa Minor is Alpha Ursa Minoris. So there's 3-letter abbreviations. Astronomers like to abbreviate everything. They've got some very unrememberable shortcuts, like HIP 11767. It rolls off the tongue, doesn't it? And finally, the other constellations that never rise are set in New Jersey. Just circle round and round the North Pole. Cassiopeia, the queen, Cepheus, the king. Now, if I were to move over to look in the west, I'll see the stars of fall disappearing. Last month and the month before, I talked about the Great Square, huge square, to look at all of the flying horse Pegasus. I have to move my head in the real sky. Here, I'm moving the real sky. See a horse? The winged horse, Pegasus. Attached to the horse, the Princess Andromeda. And if you're lucky, if you live where it's dark, you might still see the Andromeda Galaxy. From this star in the big square, the Great Square, if you go 2 stars up and 2 over, you'll see the most distant object in the universe that you can see with the naked eye. It's in the Guinness Book of World Records. The light that you're seeing left from here 2.5 million years ago. But we talked about that last time. Right here, Jupiter is close to the constellation Pisces, the fishes, almost looks like fishes. And 2,030 years ago, -1, because there was no year 0, there was a triple conjunction of Jupiter and Saturn in a constellation important to the ancient Hebrews. And that might have been the star of Bethlehem. 3 times a leader planet and a protector planet met in this constellation, the watery sign. I'll be talking about the star of Bethlehem for a group in about a week. It's going to be fun. I missed a chance to do it during the Christmas season because, I was not able to get out. I was housebound with COVID-19. Everybody stay healthy. If you look towards the south part of the sky, or southeast, you'll see the main signs of winter coming up. They're a little bit low now. Next month, they'll be even higher at 9 o'clock. Well, actually, yeah, why don't we change the time a little bit here? Going forward in time. A nice hour before it gets too late, you will see Orion almost due south this time of the year. Orion is one of the most easily recognized constellations. Kind of has four bright stars for the shoulders and knees, belt, sword, a mighty hunter holding a club or a shield, and an animal skin. Orion the Hunter. These are some of the brightest stars of the winter sky. Famous stars, Rigel from Star Trek, Betelgeuse from the movie Beetlejuice. No, nope. Betelgeuse in Arabic, Alpha Orionis, the Arabic name Betelgeuse or Betelgeuse, can be pronounced about 4 or 5 different ways, means the armpit of the giant. Orion's armpit, reddish star. Check the color in the real sky, reddish compared to bluish Rigel. Your eyes can see temperature differences. Did you know that? Yep, your eyes act like spectroscopes. Betelgeuse is a very bright, a big giant reddish star, and Rigel is a giant bluish star. 860 light years away, Betelgeuse about 500 light years away. I believe this is the star they went to in the movie Planet of the Apes, or the novel. And these stars are even further, 800, 1900. So compared to our solar system, stars are very much further away. When we say that a planet like Jupiter is in Pisces, as the astrologers say, is it really near those stars? No, the light from Jupiter is fairly close to Earth, as the Earth and Jupiter line up roughly on the same side of the sun. Well, let's see. This time of the year, Jupiter is about 5 AU away. Earth is 1 AU from the sun, 93 million miles, 149 something million kilometers. So Jupiter from the Earth is 5 minus 1 is anyone? Anyone? Arithmeticians in the audience, 4 AU, 8 1/3 minutes per AU, that's 32. So Jupiter, the light we're seeing here, left more than a half hour ago. The light from this bright red star, which you can find by lining up the belt of Orion star, hop over to the eye of Taurus the Bull, 66 light years away, more than 66 years. Jupiter, half hour, Aldebaran, more than 66 years. Stars are much further away than the planets of our solar system. So I've been using this technique, star hopping, to use the Big Dipper to find the North Star. You can do this for constellations in the winter sky. Let's zoom out a little bit. Up along the belt to find Taurus the Bull. See the horns? How about now? Face of the Bull is an old star cluster. Or I can go the other direction, downward to Sirius the Dog Star. See the dog? Almost looks like a dog. Canis Major. You know what that means. So what's Canis Minor? With its bright star Procyon. Canis Minor, small dog. Near Mono Ceros, one horn Ceros, like rhinoceros. Rhino, nose, like rhinovirus. Rhinoceros, nose horn, rhinoceros. Monoceros, one horn is a unicorn. There's a lot of interesting stuff in this part of the sky. If you can find these stars, you'll see Procyon rising before the dog. It comes up first. Pro, before Scion the dog, and the little dog. You can find the winter triangle, Sirius, Betelgeuse, Procyon. Bright winter stars. And in the winter skies, we often have the clearest skies, nice steady air. Good time to take out those binoculars or that telescope. Set it up before you freeze. Not great for temperature, but nice clear skies for seeing objects. There's a winter hexagon. I talked about this at the beginning. Sirius and the dog. The knee of Orion, Rigel. The eye of the bull, Aldebaran, another red giant star. Capella in the chariot rider, carrying the baby goats. Looks just like a chariot rider carrying the, no, huh? And finally, Pollux in Gemini, the twins rising above Orion, one of the signs of the zodiac, back down to Procyon, back to Sirius. 1, 2, 3, 4, 5, 6 winter hexagon. I just learned about that last year. All my life I've been an amateur astronomer. Didn't really know about the winter hexagon. I knew about the winter triangle. So you can always, if there's any lesson to be learned, no matter how old you are, no matter how long you've been doing it, you can always learn new stuff. That's why we are here at UACNJ to help you learn about the sky. And so there's no question that's too stupid. There's no such thing as a stupid question. Because once you ask a question and get the answer, you no longer do not know that, you do no longer have that question. If I follow Orion's belt past the face of the bull, an old star cluster, an open cluster, I see another open cluster of stars. Many people mistake this for the Little Dipper for its shape, but on close-up we see a star cluster with gas around these bright, young, bluish stars, burning through their nuclear fuel 100 times faster or more than our sun. Our sun's been around for 5,000 million years. That's 5 billion years. These stars, a fraction of that time. They're bigger, hotter, and they burn their fuel much more quickly than the sun, which has another 5 billion years to go, so don't worry. I generally see 6 stars here with the naked eye. 1, 2, 3, 4, 5. Well, 1, 2, 3, 4, 5, 6. If you have sharp eyesight, you might see the 7 sisters, or even more, 8, some of us. If you have a pair of binoculars, you might see a dozen or dozens in a telescope. Just recently, it was realized that this gas, which was thought to be the stars, the gas that the stars were born from, it might just be that the Pleiades, the 7 sisters, are just happen to be passing through this gas. New idea. Oh, and several months ago, why does the picture look square? Why does the open cluster look square? It's because this is a picture that somebody slapped onto the artificial sky of Stellarium, the square picture. Helps us visualize things, though. I mentioned unusual objects like nebulae. One of my favorites is here, down hanging below Orion's belt is his sword. And even in a small pair of binoculars, you can see a nebulosity. That means something cloudy in the sword of Orion. In a small telescope, it's beautiful. You don't see much color to the naked eye or in a telescope. But if you have a lot of light, like in a really big telescope, or especially when you take a picture at long exposure, you can see that the hydrogen gas that this nebula is made of glows with its own reddish color, and yet parts of it glow blue, just like the Pleiades. That's bright young stars reflecting their light. So there's a reflectance nebula, there's emission nebula emitting red light, and there's dust blocking starlight, dark dust. This gas and dust collapses and eventually forms stars and planetary systems. And how do we know that? Because we can see it happening. We now can see how planetary disks form, how planets form. This is a whole new era of astronomy. We're learning all kinds of new things with new technologies. That's one of my favorite nebulae, plural of nebula. You can also say nebulas. It's not forbidden. You're not punished. Nebulas, nebulae. You say potato, I say potato. tomato. One of my other favorites, oh, right nearby, a nebula, an emission nebula, or an absorption nebula, dust cloud, in front of an emission. It looks like a famous animal, the head of an animal. Recognize it? Lots of stuff going on here. One of my favorites is in Monoceros, the unicorn. Looks like a flower. Shakespeare wrote about this flower. See it? I'll let you do the research, find out the name. There are even other nebulae nearby. There are galaxies to see high up in the sky near the Big Dipper. If I face south, to look north, I have to crane my head backwards. Ouch. If I did that, though, very high up in the sky near the zenith, that's the point right overhead. Whoa, I can't even control it too well because I'm going around in circles. We see Perseus, the hero who rescued Andromeda, the princess, with her galaxy, the Andromeda galaxy. And he is holding the head of the Medusa with the eye of Medusa, the bright eclipsing binary Beta Persei, Algol. Algol eclipses every few days. The two stars revolve about each other, and we happen to be lined up in a straight line with them from Earth, so that as one passes, it passes in front of the other, you see an eclipse. Very cool. Right nearby, to the naked eye, you could see the famous double cluster of stars. Two open clusters, one near the other. And I have glimpsed these from UACNJ, where the skies are still pretty dark. Sometimes I've actually glimpsed that with the unaided eye. Little fuzzy patch near Perseus. Well, I've seen a lot. I've been talking about a lot. I want to pause here just to do a quick review. What you might want to do, once you've gotten used to where things are by finding north, turn around, you face south. First thing you do is you go out, right? You look for the letter S, right? No? Do you have a letter S in the real sky? In the real sky, I can control everything. I can control markings. I can turn things off. I can do labels, markers. I can make things twinkle, endless control. But I'm going to leave up the cardinal points so we know where we're looking. I face south, and if I want to start low in the sky, I would look for Orion first. I would star hop down to the dog, Sirius. The second brightest star in the sky, 8.6 light years away, 8.6 years ago. That's how you're seeing what the star looks like. Not now. There's a delay. Every time you look at something in the sky, you're looking back in time. You're looking at Betelgeuse 500 years ago. You're looking at Alnilam in Orion, the middle of the belt, 1977 years ago. Now, looking at the Milky Way, some of this light came to us from towards the center of the galaxy 30,000 years ago. Jupiter, half an hour. Up along the belt to find the Hyades star cluster, the face of Orion, and the Seven Sisters. The Milky Way is beautiful from UACNJ. Later on at night when it's really dark, you might see it better. There are ways to exaggerate its brightness. It goes over the whole sky in the winter and in the summer. It's really something to see. We invite you to join us. Visit. And finally, looking higher up in the sky, past or close to the chariot rider, almost unmistakable is the twins, Gemini. Two different colored stars, yellowish Pollux and bluish Castor. What would the sun look like from far in space? Kind of like that, kind of a yellowy color. So I challenge you to see some of these things. I want you to come on back for what's up in the February and March skies, when we'll see more and more of this backwards question mark and triangle, the sign of the zodiac, the sun, the moon, the planets all pass through the signs of the zodiac. And that's a path that we can draw in space. The ecliptic, if you were to draw the orbit of the Earth out into space, it would mark where we find the sun, the moon, and the planets. For the major planets orbit pretty much flat in the same plane, close to the plane of Earth around the sun. And so that's why we find Jupiter there. And the bull, Taurus, and Gemini, the twins, and Cancer, the crab, and Leo, the lion. What about this little one here? Let's end this part of our talk tonight with something that leaps through the sky. Lepus. See the ears? What is this? Should I give you a moment? You ready? Lepus the hare. H-A-R-E. I'm going to come back to this if there are any questions. And just mention that there are good ways to get started in astronomy, affordable ways like smaller binoculars. If your eye doesn't open to the way it did when I was young, 7-millimeter pupil, you don't need binoculars that give you a big exit cone of light. It's called the exit pupil, right? You can, binoculars like these cost well over 200, used to cost well over 200. 20 by 80, what does that mean? Well, the first number is the power, the magnification. Things look 20 times bigger than to the naked eye. And the second is the size of the lens in millimeters, metric millimeters, 25.4 millimeters to the inch. So that's pretty big, 20 by 80s, and that's why they're more expensive. For those of you who are older, 5 by 35 binoculars give you a 7 by 35, 7 power, 35 millimeters give you 35 divided by 7 is 5-millimeter exit pupil. That's about the size of your pupil. If you have a standard 7 by 50 binoculars, 50 millimeters divided by 7 is, anyone? 7 millimeters. That's good if you're young. You can use all of that light. But the cone of light gets cut off as we get older, and the pupils of our eyes don't open so much anymore. That's a good way to get started. If you get bored looking at the sky, you can do other hobbies like spy on your neighbors or watch birds. I don't recommend spying on your neighbors. It's not polite. Getting started with telescopes are much more affordable than when I was growing up, and everything cost more than $200. The Celestron first scope, I saw this priced at $67. Might want to buy yourself more eyepieces. It's a mirror on one end, an open tube on the other, and a second mirror here, so that when the light comes in and bounces off the mirror, it comes over here and gets deflected to the side where you can put in your eyepiece and see stuff. If you want to get more light than you can with the first scope, for a little more money, you can get the less expensive design, the Dobsonian style telescope, where you get a lot of bang for your buck if you want to look at faint objects. Again, mirror on the bottom, open tube, second mirror, and to the side. These telescopes have little telescopes on the side called finders. You look for something in there first, it's lined up with what you see in here. And when you come visit us at UACNJ, you'll see the amateur astronomers all laying out their equipment. Please don't kick their tripods and mounts. You will make an astronomer cry. But they are very willing to show you what's up in the sky besides our other observatories. The Barry Malpass Observatory, the Lonny Buinis Observatory, all open to the public year-round, except for when it's too cold. That's quite a few months in New Jersey. I got some homework for you. Oh no! Well, it's easy to remember UACNIJ. Say after me, UACNIJ.org. That's our website. A lot of good references. It's an umbrella organization of many clubs in New Jersey, New York, Pennsylvania, mostly New Jersey. Magazines, a lot of good free stuff at skyandtelescope.com or org. and astronomy.com. They're also in print. You can also subscribe in print or online. But I have to say, I'm very impressed with how much stuff is online for free. You can get their mobile apps. And you can, if you forget everything else I've said tonight, everything, even if you forget my name, please don't forget space.com, which has a lot of good reference. Search for life, news. I mentioned Stellarium. You saw that I was using that to simulate the sky. It's free to download and install. It's free to use online
I'm
if you don't want
gonna
to install.
make my
It's
mic
free.
hot soon.
Sorry? Well, that's okay. Free app. And Celestia is also free. Lets you fly out into space. Celestia, cool. So here's my review. Don't forget, meteor shower, missed it. New moon coming up. Great time to see what? Nebulae, star clusters, galaxies. Mercury, January 12th in the morning. If you don't like getting up early, try next month. We'll talk about the eastern elongation again. And then full moon for finding faint objects. That's the official scientific terminology for finding faint objects. The full moon is, repeat after me. Here's how you can find me, astronomyinmotion.com. A lot of free 3D planets to play with. You can use your fingers on mobile devices. You can use a mouse or a joystick. And if you want, you can buy the really fancy Mars at your fingertips. 4K video, 28 videos go with it of every crash landing site, every landing site, and major features of the planet Mars. There's a free version at marsatyourfingertips.com in HD with limited features, but absolutely free. And if you come to visit us in the warmer weather, we will tell you, find us on Facebook, Discord, Patreon, YouTube, Instagram. We're everywhere, everywhere. Thank you very much. You've been a good audience.
All right. Thank you so much, Lonnie, for another great presentation telling us what is going on in the sky this month. So we're going to get right into our question and answer session. And one of our observers actually had made a comment for you that he loves that you correctly use the term dark side of the moon to refer to the dark side of the moon. A lot of people use it incorrectly and confuse the dark side of the moon with the far side of the moon.
Right, good point, Kim, because we can see the dark side of the moon now. If it weren't snowing tonight and you went out, you would see the crescent on one side and you'd see the dark side of the moon to the right, right? So let's all call it the far side.
Yeah.
The other side.
Just because we can't see it doesn't mean it's in the dark. It is not
right.
Like.
Well, you know what you could do? Take a ball, tennis ball, baseball, light it up with a flashlight, and then have somebody look around at different angles. You'll see phases. You'll see only one half at a time, but there's always half lit up.
I mean, technically, turn off the lights in the room, and except for this lamp, we can have a live demonstration using my head. But that would be a little bit weird.
Right, and we're not weird at all.
Nah, never. All right. So our next question is based off a comment that someone said that we're getting into galaxy season where we need to get the big scopes out. What is the largest scope that you have?
Well, let's see. I know there were plans, I'm not sure if it's done, to install is it a 24 inch, but typical sizes are 14 to 16 inches, which is tremendous. You can use that for research. I
think they were more wondering what you have personally.
Oh, my biggest telescope is 90 millimeters, which is divided by 25, 3.5 inches, which is good for planets, and you can still see quite a bit with that. Not if you want to find Pluto, though. You need at least a 12-inch telescope for that.
All right. Someone says they have a 150 millimeter Mac and a 127 millimeter refractor. I personally have
Ooh,
an 8-inch Dob that
nice.
I still need to get out, and although it has seen first light, it needs some use. Last season was not kind to any of us as far as
No.
weather and skies. All right. So our next online question is, are there any plans to reduce communications lag between the Earth and other places in the solar system or farther?
I didn't understand the first part. To do what to the
To
communications?
reduce communications lag. Like you said, it takes like
Oh,
30 minutes to get input back from something out in the orbit of Jupiter if it's traveling the speed of light.
right, right. Well, as far as communicating with spacecraft, it's an immutable law of physics that information travels at the speed of light. So no, we can't reduce the lag, the communication lag across the solar system. Eventually, traveling to the stars, there may be a way to warp space, just like Star Trek. Yeah, space warp. It's theoretically possible, but it would be an immense undertaking from an engineering standpoint, and it would require materials that may not exist in our universe. So, unfortunately, the answer to your question is we can't do much.
Yeah, I believe, yeah, someone in chat, Misadventures in Astro, who actually also streams about astronomy, said they were trying to do some fine tuning on how we communicate with things, where they did the laser communication tech like 2 weeks ago with the Psyche mission. So,
Right. For the moon, it's not bad. It's like a second and a quarter each way. So there's a delay.
yeah, it, any gamer can tell you all about communications delay and lag.
Oh, yeah. Yep. Yeah, the problem, everybody, is light is slow. So slow.
That's the fastest thing that we know of.
Yep.
Right. I also put a note to myself that I need to put on the to-do list, put cardinal directions around the presentation area and observe the observe field
Oh,
so that you can't say, no, you won't see us. And I'm like, yes, you will. It's right there.
okay.
All right. So if anyone else has any questions, I do ask that you get those in chat. Uh, while I'm just giving them a few minutes, because as we discussed, communications lag is a thing. I want to thank Yulani for another great presentation. I want to thank you all for who have joined us here on Twitch and YouTube. Uh, YouTube, I think when I checked yesterday, we're I believe 16 subscribers off of 500, so that's exciting. And I want to thank everyone who has liked, followed, subscribed, because it does help us uh, grow our channel and get the word out to various people. Like Lonnie has said, check us out on our website, uacnj.org. I'll toss a link. There's already a link to that in chat, as well as our socials. Like I said, we are going to be having a few special events. One of which is the for the solar eclipse in April. Uh, we also look forward to seeing people at NEAF, the Northeast Astronomy Forum. I think that's the correct acronym.
Yes.
Okay, I'm like, I always there's so many acronyms in so little time, so it's always did I get the correct one this time? All right, so it does look like that was the oh nope, I missed a question. That is bad of me. The question is, are the Pleiades going to pick up that gas as they pass through, or is it more of an optical closeness instead of an actual closeness?
Ooh, I don't know the specifics of that. I just read that they were speculating that it's passing through. I'll have to see if they actually have any distance estimates. I don't know. I'll find out and I'll try to answer that next month.
Yeah, that is actually a great question because
Mhm.
much like stars, where you're like, that's a double star because it appears close, but in reality, it's like,
Right, right. Like that's like the double star in the Big Dipper's handle. There's one in front of the other.
so excellent question. Uh, like I said, like Lonnie said, we will double check that and get back to that later. So that looks like it has dried up our questions. Thank you, everyone, for joining us. We once again wish everyone a great new year. Happy 2024, clear skies, and good seeing.
And I want to thank Kim and everyone at UACNJ who made this possible. Couldn't be done without all the technical help.